Okay, finishing up the notes. So, how to graph a polynomial equation if you have it in factored form. The roots are the same thing as the zeros. So we're looking at the factor x minus 3 gives us the 0, 3, and its multiplicity is 1 because there's an understood 1 exponent. And then for the second factor, we are getting negative 2 makes that factor equal to 0, and it also has an understood 1 exponent, so its multiplicity is 1. And then for our third factor, x equals 1 makes that 0, that its multiplicity is 2. And so that's writing the roots down. The intercepts, the x-intercepts are the same thing as the roots. So the x-intercepts are 3, negative 2, and 1. To find the y-intercept, you're going to plug 0 into the x and see what you get for y. So I'm going to take this entire expression, and I get 1/3 times, when I plug 0 in, I get negative 3, times 2 when I plug in 0, times negative 1 squared when I plug in 0. The negative 1 being squared will end up being positive 1. And these two together will make negative 1, and then multiplied by 2 gives me that negative 2 is the y-intercept. The next thing is the leading coefficient. And as long as the factors with x are written where x is leading it and no number is in front of the x, then the number that leads that polynomial in its factored form is your leading coefficient. And I will always write your polynomials in that way. You can figure out the degree by adding the multiplicities. So multiplicity 1, 2, and then 3, 4. This is a degree 4 polynomial. The end behavior can be determined based on the sign of the leading coefficient and whether the degree is even or odd. The leading coefficient is positive, so that means that when x approaches positive infinity, we head up. F of x approaches positive infinity. Because the degree is even, an even number, the left end will do the same thing as the right end does. So as x approaches negative infinity, f of x will approach positive infinity. Now, we're going to bring all this together to create a graph. I'm going to start with the end behavior. I'm going to erase this excess, and then starting with the end behavior, the fact that the two ends are heading up. The next thing I'm going to do is plot all the intercepts. My x-intercepts are 3, negative 2, and positive 1. My y-intercept is negative 2. And the next thing I'm going to do is look at the multiplicity of the roots. And what I can do is I can start with the left end of my graph, and knowing that it's up at positive infinity, it's going to head down, and the first x-intercept I hit is negative 2. That intercept, that root, or 0, is a multiplicity 1. So it's going to slice through. So I know that I'm basically coming in and slicing. Then I don't know how low this goes, and I don't expect you to know how low it goes. But you know it has to come back up to the x-intercept of 1, and it has to go through a y-intercept of negative 2 somewhere along the way. When I do get over to the y-intercept or the x-intercept of 1, that multiplicity is 2. I'm going to be bouncing off the x-axis and not experiencing a sign change, so something like that. And then as I get close to x equals 3, for the last x-intercept, its multiplicity is 1. I'm going to slice through the x-axis. I'm not expecting you to know everything about the graph, but just get a basic feel for some of its essential features. I'm going to show you the answer. The answer is definitely going to look different from any basic sketch that any of us do, unless you're really that good, but this is what it actually looks like if you were to look at it on a graph. Now, how would you possibly know that it goes all the way down to here? You don't. That's not your job at this level in math. At this level in math, your job is to understand the end behavior, to be able to find all of the intercepts, but also to understand how multiplicity affects the graph as it goes around or through the x-axis. So the slicing through, the bouncing off, and the slicing through. These are the only things that I expect you to be able to get correct when you are graphing your polynomial function. Oh, and the y-intercept. Other than that, it's not going to be perfect, and that's okay. Then going on with the rest of the classwork, here is another example. I start off with the roots or the zeros. I have an x sitting there as a factor. That gives me a 0 of 0. There's an understood multiplicity of 1. And now I'm going to erase that pen mark from there. So you can see that x is a factor. That means you have a root 0 with multiplicity 1. Then I have x plus 3 squared. Negative 3 makes that equal 0. And there is a 2 exponent, so it has multiplicity 2. Then I move on to my next factor, x minus 2 squared. The x value of 2 makes that equal 0. Its multiplicity is 2. These three roots are the x-intercepts, and all you need to do is list them, 0, negative 3, and 2. To find the y-intercept, you are going to plug 0 into all of the x's. So when I plug 0 into all of the x's, I have negative 1/5 times 0 times, how about I just stop right there? If I have to multiply by 0, my y-intercept is 0. For the leading coefficient, as long as every factor that you see with an x has x being just multiplied by a 1, an understood 1 in front of it, then the very front number is your leading coefficient. That means the leading coefficient is negative 1/5. The degree is the sum of the multiplicities. So I have multiplicity 1, 2 more, and another 2 for a total of 5. I can determine my end behavior by first looking at the leading coefficient. The leading coefficient is negative. That means on the right end, I head down to negative infinity. Then the next thing I look at is my degree. I have an odd degree. That means that the left end will do the opposite sign to infinity. And now I've got a little bit of information to graph. So this is saying the right end of my graph heads down. The left end of my graph heads up. Then I'm going to plot my intercepts. My intercepts are x-intercepts of 0, negative 3, and 2. My y-intercept is 0, so it's already there. And then I want to pay attention to the multiplicities as I go from up here at positive infinity and move left to right. I don't know how far down or how far up it goes before it turns. That's okay. The first x-intercept I'm going to hit is -3. -3 has a multiplicity of 2, so I will bounce off the x-axis. Bounce. The next x-intercept that I have is going to be 0. My root of 0 has multiplicity 1, so it will slice through the x-axis. Now, how high does my graph go in between? I don't know, but I know it has to be drawn smoothly and come back down to slice through the x-axis. Then 2 is the very last one, +2. +2 has a multiplicity of 2, so I will bounce off the x-axis on that one. So I don't know how far down I go, but I do know I have to come back up and bounce off. And again, all you need to be able to get correct are the end behaviors, and then following those end behaviors through the x-intercepts, you have a bounce, a cross, and another bounce. And the side of the x-axis that you're on happens naturally if you know the end behavior and you know whether you go through the x-axis or bounce off the x-axis from the side that you are on. Let's take a look at what that actually looks like. That's what it actually looks like. And perfection is not expected, just some basic things. I want to say again, end behavior, bouncing off the x-intercepts, crossing where they should. Those are the things that are being looked at. And then over here, for this next one, you need to write an equation for the polynomial graph. And C is your leading coefficient, which we will be looking at. But first, the Z1, Z2, and Z3, those are just basically expressing the x-intercepts, the roots. What you want to see is you have an x-intercept of -1. That's a 0. That Z1, Z2, Z3 stand for zeros. So -1 is a 0. Do you see that it bounces off the x-axis? That means that it has a multiplicity of 2, or it could be 4, 6, 8. My other x-intercept that I know is 2, so that's another 0. Because it slices through the x-axis, that has a multiplicity of 1. Based on those two zeros, that means that I have the factors x minus -1 and x minus 2. It's always x minus the 0 is what this up here is saying. X minus a 0. Then I need to look at the multiplicity. For -1, I have a multiplicity of 2, so I put an exponent 2. For the 0, 2, I have multiplicity 1, so I don't need to put anything down. And then for the leading coefficient, this particular graph, I can see that I have a y-intercept of 4. Based on that y-intercept, I can find what my leading coefficient is. Because so far, based on my zeros, I know that I have this kind of equation. Because I have an extra y-intercept that I can see clearly what it is, I'm going to take the point 0, 4, and I'm going to plug 4 in for the y. I need to find out what my c is and plug in 0 for the x. And that gives me 4 equals 1 c times 1 squared multiplied by -1. So I'm getting -4 for my leading coefficient. And now I'm ready to write the polynomial. It is leading coefficient times, and then just start putting in the factors with the exponents based on the multiplicity of those zeros. And that at least gets you to the factored form. This says write an equation for the polynomial in factored form. This is factored form, therefore you are done. Now, I didn't get to the point of talking about multiplication, and you may already know how to do multiplication, but I will go through these examples and show you. I have x squared plus 3x minus 1 multiplied by 2x squared minus 5x minus 1. I need to multiply the whoever's leading each box for its column and its row. So this particular box is going to be found by multiplying 2x squared with x squared, and that will be 2 times x to the 4th power. The next box will be found by multiplying -5x and this x squared. -5x times x squared gives me -5x to the 3rd power. And then this box will be found by multiplying -1 by, again, x squared. That will be -x squared. Then I move on to the next row. I'm going to erase that. See if I can erase some of these without erasing everything else. And now I'm going to, for everybody in this row, multiply 3x by what is on top. So 3x times 2x squared is going to be 2 times 3, 6. And x times x squared gives me x to the 3rd power. Then I'm going to multiply -5x with the 3x to give me -15x squared. And then finally, I'm going to multiply the -1 by 3x to give me -3x. And for the last row, I have -1 multiplying by 2x squared, and then -1 multiplied by -5x, and -1 multiplied by -1. Once you have done that, then it is a matter of lining this up. So with lining it up, it actually goes along diagonals. And if you start with the upper left box, you can add diagonals while you go along, and you are in standard form already. I'm starting with 2x to the 4th, and then when I add these two together, I have +6 minus 5 of the x cubes. That gives me +1 of the x cubes. And then next I have -2x squared plus -15x plus -x squared. So I have -2 minus 15 minus 1 gives me a total of -18 of the x squareds. Then for the x's, I have 5x plus -3x gives me +2x. And then lastly, the lone 1. And I am already in standard form if I add it in that manner. Next, you do not have to line things up the way I'm about to show you, but it is helpful so that you can do these diagonals of adding like terms the way that I just discussed. So when I write x cubed minus 5, I'm going to write x cubed plus 0x squared plus 0x minus 5. And then for the polynomial, the second polynomial, I have x squared plus 9x minus 8. So if I start with my largest degree term and I count for every exponent down all the way, even putting zeros right there, then I will have an easier time when I find my like terms. You do not have to do this. It's just a way of lining things up to more easily see it. And it's up to you how you want to do it. Then I am going to multiply x cubed and x squared to get x to the 3 plus 2, 5. Here I'm multiplying 9x by x cubed. Here I'm multiplying negative 8 with x cubed. As I go across these two, I'm just getting 0. But for the purpose of adding like terms, I want to look at I have 0 of x squared times x squared. And I have 0 of x squared times x. And I have 0 of x squared times negative 8. And then here I have 0x times x squared is 0x to the third power. 0x times 9x is 0x squared. 0x times negative 8 is 0 times negative 8 times x. And again, I want to emphasize you do not have to do these two rows that I just did. But what it does is it lines up x to the fourth, x cubed, x squared, and what we're about to get here, x, and then constant. And that helps some people. If you don't want to do it, don't do it. I'm going to take those highlights away. And now the last row. Negative 5 times x squared, negative 5 times 9x, and negative 5 times negative 8. And then I'm going to go through and add my diagonals. And that is going to give me x to the fifth plus 9x to the fourth. And then minus 8x cubed. Next is negative 5x squared. And then negative 45x. And lastly, plus 40. And you have that all added together and already in standard form. And then I have 2 more of these and we will be done. So next I have multiplying 2x minus 1 with x to the fourth minus 3x cubed plus x squared minus 5x plus 12. Here I'm multiplying 2 times x to the fourth. Here I'm multiplying 2 times negative 3 times x cubed. Here I have 2x times x squared. Here I have 2x times negative 5x. And then over here I have 24x. Then row 2, I have negative 1 times x to the fourth, negative 1 times negative 3x cubed, negative 1 times positive x squared, negative 1 times negative 5x, and negative 1 times positive 12. And I again have those same diagonals. I have my x to the fifth diagonal, x to the fourth, x cubed, x squared, x, and a constant. That gives me 2x to the fifth minus 7x to the fourth plus 5x cubed minus 11x squared plus 29x and then minus 12. And again, I'm already in standard form if I added it in that manner. One more. I am multiplying 2x cubed plus 3x squared minus 4x plus 2 with x cubed. Now, I don't have an x squared term. The next thing I have is an x to the 1 power, so I'm missing x squared. I can do a placeholder column of 0x squared. I don't have to, but it will line things up. Then for my x, I have negative 5x, and finally plus 7. Now, I do want to say that if you just go down this column, if you want, you can just say it's all 0. You don't have to sit there and write things the way I did in this previous problem where I put the x to the power that goes with it, because in a way it doesn't, if you're getting 0, you're getting 0, you know? So now I'm going to multiply. 2x cubed and x cubed is 2x to the 3 plus 3. Here I have negative 5 times positive 2, and then x to the 3 plus 1. 7 times 2 gives me 14, and then multiplied by the x cubed over here. For row 2, I'm multiplying a 3x squared through. So first times x cubed, I get 3 times x to the 2 plus 3. 3 times negative 5 gives me negative 15, and then x squared times x is x cubed. 3 times 7 is 21, and also multiplying is x squared. For row 3, I have negative 4x multiplying to x cubed, and then multiplying to negative 5x to give me positive 20x squared. And then negative 4x multiplied by the 7 gives me negative 28x. For the last row, I have 2 times x cubed, negative 10 times x, and 14. And now I can add my diagonals, my x to the 6th diagonal, my x to the 5th diagonal, my x to the 4th, my x cubes, my x squared, my x's, and then my lone constant. And that gives me 2x to the power of 6 plus, for my 5's, I only have 3x to the 5th. For my 4 power, I have a negative 4 and a negative 10, giving me negative 14 of the x to the 4ths. For my 3rd power, I have 2 minus 15 plus 14, giving me positive 1 of those x cubes, so positive x cubed. My x squareds, I have 20 plus 21, giving me 41 x squared. My x's are negative 10 plus negative 28, giving me negative 38x. And my lone constant, plus 14 for that. And I am already in standard form, and I am done. That finishes classwork 4.4.